Let's look. So we know that delta E is equal to Q plus W. And we know delta E, negative 9.55 times 10 to the third kilojoules is equal to our heat Q plus our work W. Now, it says that the system does 7.05 times 10 to the fifth kilojoules of work. So is that a positive or a negative sign, class? Negative. So plus a negative 7.05 times 10 to the fifth kilojoules. So now all we have to do is rearrange. Negative 9.55 times 10 to the third kilojoules plus, adding this to both sides, 7.05 times 10 to the fifth kilojoules is equal to Q. Now, you can do this on your calculators, but sometimes I will just change this so that they both are in the same exponent to be better able to handle sig figs. And we get 6.95 times 10 to the fifth kilojoules. So you do have to be mindful of the sig figs, and we can keep 3. So the heat is positive in this case, not negative. No. The final answer has to be mathematically correct. And unless you're doing a problem on a test that says put this in scientific notation, I don't care as long as it's mathematically correct. If you want to write out all those zeros, go for it. Okay, so now we're going to look a little bit at this situation of the work that comes into chemistry. The work that we do in chemistry is usually with gases, and it's usually pressure volume work. So we define work, W, as equal to minus the pressure times the change in volume, negative P delta V. And we know that delta E, the energy change, is equal to Q plus W. So delta E is Q plus a negative P delta V. Now, in chemistry, we often do things with gases in sealed containers so the volume remains constant. If the volume is constant, delta V is 0. So we would then have that delta E is equal to Q plus negative P delta V, and if delta V is 0, this term becomes 0, so delta E is equal to Q. So this is what's important, is that when we are dealing with a system at constant volume, we don't have any work, we only have heat. So for us in chemistry, we generally only work with heat if we have a constant volume system. It's more common for us to have things that are at constant pressure. And when we're at constant pressure, we introduce a new term, and we call it enthalpy. And we use the letter H to describe enthalpy. And enthalpy is equal to the energy plus the pressure times the volume. This is a definition. Therefore, delta H is delta E plus P delta V. And since delta E is Q plus W and W is negative P delta V, then at constant pressure, delta H is Q plus a negative P delta V plus P delta V. So delta H is equal to Q, which is the only thing you need to remember about this, is that at constant pressure, we have only heat. So enthalpies are just heat, and that's what we're going to be working with. So the enthalpy is the heat energy of a system that's open to the atmosphere at constant pressure. And again, we cannot measure actual heats and actual energies because it takes energy to measure them, so we measure changes. So the change in enthalpy, delta H, is the final enthalpy minus the initial enthalpy. For a chemical reaction, final is products and initial is reactants. So for us in chemistry, delta H is the enthalpy of the products minus the enthalpy of the reactants. And these can be either exothermic or endothermic, two vocabulary words. When it is exothermic, then heat exits the system. and exit is exothermic. It feels hot, and we have a negative sign because heat is a product. If it is leaving the system, it's a product. When we have endothermic, heat enters the system. So enters is endothermic, and it feels cold. We have a positive sign, and heat is a reactant. So these vocabulary words are important because occasionally you might read something that says, in an exothermic reaction with a heat of 25 kilojoules, the word exothermic tells you to put a negative sign in front of that 25 kilojoules. So you'll sometimes have to pay attention to that. Then we also discuss standard enthalpies. So standard conditions for enthalpy changes are 25 degrees Celsius exactly, or 298.15 Kelvin, and 1 atmosphere pressure. And when we are at standard conditions, we add this little superscript 0 to the delta H, and that is a way of telling us what the temperature and pressure of that system is. Sometimes that'll be your only clue in the problem where you need temperature of what the temperature is. So you have to learn to recognize that little superscript 0.